So this question is from CS 2017. The question is from the limit. We have to evaluate this limit. So if you put the 0 in this limit, then you are going to get the 0 by 0 form. What you can do is you can apply the L'Hopital rule, and after applying the L'Hopital rule, so what you will do, you will differentiate to numerator and denominator. So that is going to be 7 to the power 6 minus 10 x to the power 4 divided by 3 x square minus 6x. Right, now you can put the limit. So you are going to get 10 minus 7 minus 10 and 3 minus 6, that is 1. So correct answer for this is C. So this question is from CE 2017. We have to evaluate this limit. So if you try to put this 0, then what you will get, that 10 0 is 0 and the denominator is also 0, so 0 by 0 form. So what you can do, you can apply the L'Hopital rule. So the differentiation of 10x is sec square x, and we are going to get 2x minus 1, that is limit x tends to 0. Now you can apply the limit. So sec x sec 0 is 1, and here we will have minus 1. So the answer for this is minus 1. So this question is from ME. We have to evaluate this limit. So this again, this is based on the L'Hopital rule. If you put this limit 0, then what you will get is 0 by 0 form. You can apply the L'Hopital rule. That would be limit x tends to 0, 3x square minus cos x divided by 1. Now put the limit. So 0 minus 1 divided by 1, so minus 1. So this is from CSE 2016. So this limit, so if you recall, then we have the results of limit that are very important. So the answer for this is 1, right? And you should know the following limit, that limit x tends to 0 and sine x divided by x is equal, that would be 1. So if limit x tends to 0 and this is approaching 0, then that would be 1. You see that x is equals to 4. If you put here 4 and here 4, that would approach to 0, right? So you can use this, that will give you answer 1. Similar to that, we have more trigonometry's important limits, that is limit x tends to 0, 10x divided by x, that is also 1. And with the inverse trigonometry, we have limit x tends to 0, sine inverse x divided by x, that is also 1. And similarly, we have limit x tends to 0, tan inverse x divided by x, that is also 1. And with the similar analogy, we have limit x tends to a, sine x minus a divided by x minus a, that is 1. And we have limit x tends to a, similar for tan x minus a divided by x minus a, that is 1. Okay, and one more thing, that is limit x tends to 0 cos x, that is going to be 1, right? And one more thing, that is limit x tends to 0 sine, if it is degree, x degree divided by x, then we will have pi divided by 180 degree, right? So this you need to take care of. Otherwise, these are the known trigonometrical important limits. So this question is from PI 2016. So this is exponential limit, right? And we have few important exponential limit that we should have. That is the first one, limit x tends to 0, a to the power x minus 1 divided by x, right? So that will be equal to log base e to the power a. With the similar analogy, we have the second property, second important limit, that is the x tends to 0, e to the power x minus 1 divided by x, right? So now at this place. Instead of a, it is e. So that would be log e to the power e, that is 1. Right? And how we can achieve this? So you can use the uh, expansion of e to the power x, that is 1 plus x plus x squared divided by 2 factorial plus x cubed divided by 3 factorial, and so on. Now let's solve this question. So we can write this question as limit x tends to 0 e to the power 5x minus 1 divided by x, that is the one thing, and there is no harm in writing this square in terms of multiplication and applying the limits to individual one, right? It is 5x minus 1 divided by 5. So this is going to be log e to the power 5x. So log e to the power e 5, right, into log e to the power 5. So that is going to be 5 into 5, that is 25. So these two you should have known. So this question is from ME 2016, and we have to find this limit. And if you see, if you put this infinity, then it is going to take the form infinity minus infinity. And if it is this form, then how you generally solve is you rationalize, right? So let's rationalize this expression. So x squared plus x minus 1 minus x. So you will multiply and divide by x squared plus x minus 1 plus x divided by root over of x squared plus x minus 1 plus x. This is what you are going to do, right? And the limit x tends to infinity. Now do the calculation. What we will get is x squared plus x minus 1 minus x squared divided by root over of x squared plus x minus 1 plus x. This will get cancelled, and that limit x tends to infinity is there. Now you can take this x common, right? That will be 1 minus 1 divided by x, and in denominator you can also take this x common. Then here we will have 1 plus 1 divided by x minus 1 divided by x square and plus 1. Now you can put the limit, that is x tends to infinity. Now this x will get cancelled. Overall you will get 1 divided by 2, right? This will get to 0, this will get to 0, and root over of 1 plus 1, that is 2. So 1 divided by 2. Now this question is from ME. We have given to evaluate this limit. Now if you put 0, then what you will get is 0 by 0 form, right? If then what you can do, you can simply apply the L'Hopital rule. That will give you, so what you can do, that you will differentiate numerator and denominator. Then you will get 1 plus 4x, 1 divided by 1 plus 4x into 4 divided by e to the power 3x into 3, and limit x tends to 0. So now put the limit, you will get 4 divided by 3. So this question is from 2016 IN. So we have to find this limit. So you see that if you put this infinity, then you will get this infinity minus infinity form, right? If this is the case, then what you are going to do, you are going to rationalize your expression. So that will, but this is what you can do. So n square plus 1. Now you will multiply and divide by n square plus 1 plus root over of n square plus 1 minus, so divided by root over of n square plus 1 plus n plus root over of n square plus, right, the limit n tends to infinity. Now here you will get n square plus n minus n square minus 1, and this expression, that is n square plus n and plus root over of n square plus 1. This n square, this n square will get cancelled. Take the n common, 1 minus 1 divided by n. Take the n common, so here you will get 1 plus 1 divided by n plus here you will get 1 plus 1 divided by n square. Now you put this limit, so this n will get cancelled and 1 divided by root over of, so this will be 0, this will be 0, root over of 1 plus 1, that is 2, that is 0.5. So the answer for this is 0.5. So this question is from CS 2015. Now if you put this limit, what form you are going to get? That is infinity to the power 0. So that is one of the indeterminate form. So we can proceed with this kind of question. We can assume that y is equals to limit x tends to infinity 1 plus x square e to the power minus x. Now what we can do, we can take log both side. So that is going to be limit x tends to infinity log 1 plus x square into e to the power minus x. Right now, so you cannot put still the limit because that will be one of the other indeterminate form, that will be infinity into 0 form. Right, so what we can do, maybe we can put this e to the power minus infinity, e to the power minus x to here, e to the power x. Right, now this will be of the form infinity by infinity. Now we can apply the L'Hopital rule and we can differentiate. So that is going to be 1 divided by 1 plus x square into 2x divided by e to the power x. Right, so that will be 2x into 1 plus x square e to the power x. Now still it is in form of infinity by infinity. Now we can apply again, double differentiate it. So that is going to be 2 divided by e to the power x. Here we will have to apply the chain rule. So e to the power x plus x square e to the power x plus 2x e to the power x. Right, and limit x tends to infinity. Now that is going to be 2 divided by infinity, right? That will be 0. So what we get is log y is equal to 0. That means y is equal to 1. Right, so that is what we want to find, y limit. So that is 1. So C is the correct. So this question is from CS 2015. This is similar to last question, right? So if you put the limit, that is going to be infinity to the power 0, right? So how we can proceed with this kind of question? We can take y is equals to, so we can take y is equals to limit x tends to infinity x to the power 1 divided by x. Now we can take the log both side, that is going to be limit x tends to infinity log x, and that x will be in multiple here. Right, now if we apply the limit, then it is going to be infinity by infinity. Right, now we can apply the L'Hopital rule, that will be 1 divided by x upon 1. Right, so that will be 1 divided by x, limit will be there. Now if we apply the limit 1 divided by infinity, that is going to be 0. So that means log y is equal to 0. That means y is equals to 1. So here what we want to find is y, that is equals to 1. So see that. this from ME 2015. So we have to evaluate this limit, right? Now if you put this 0 here and here, then you will observe that this is the 0 by 0 form. That means you can apply the L'Hopital rule. Then it will be limit x tends to 0, that is going to be sine x square into 2x divided by 8x to the power cube, right? Now, and here is x. Okay, so now let me rearrange it. So that is going to be cancelled. Here we will have 1 by 4 sine x square divided by x square, right? And this limit x tends to 0. We have this, right? Limit x tends to 0 sine x divided by x. So here x tends to 0, x tends to 0, x tends to 0, then this is going to be 1. So we can apply the same. So limit x tends to 0, 0, 0, that means this will be 1 divided by 4 into 1, that is 1 by 4. So this question is from ME 2015. Now if we put x is equal to 0, then it is going to be 0 by 0 form, right? Now that means we can apply the L'Hopital rule. So that means limit x tends to 0, that is going to be minus cos x divided by 2 cos x plus x into minus x sin x plus cos x. Now we can, that will be 1 divided by 2 plus 0 plus 1. So that is going to be 1 divided by 3, that is 0.33. Okay, so let's look at this question. So this question is from CE 2015. Now we have to evaluate this limit. Now if you see, if you put this limit x tends to infinity, here we will get 1 to the power infinity. This is one other form of the indeterminate, 1 to the power infinity. So if this is the case, then how you are going to solve, you are going to assume this expression, that is fx. So if limit x tends to a fx is equal to 1 and limit x tends to a gx, that is equal to infinity, then what you can use is this e to the power limit x tends to infinity, here x tends to a, then fx minus 1 into gx, right? You can use this one if it is a it has a form of 1 to the power infinity, indeterminate form, and fx is 1, limit x tends to fx, limit x tends to a fx is 1, and limit x tends to a gx is infinity, then you can use this, right? So if you see that this is your gx, then this will be limit x tends to infinity, that will be e to the power, right? E to the power limit x tends to infinity, fx is 1 plus 1 divided by x minus 1 into gx is 2x, right? So that will get cancelled, this will get cancelled, so you will get e to the power 2. So the answer for this. Okay, so this question is from CE and from 2014. Now we will have to evaluate this limit. So limit a tends to 0 and x to the power a minus 1 divided by a. So here one point to take care is that here we have given this a tends to 0, right? Then this x is going to be your constant, right? Now if you put a equals to 0, then what you will get is 0 by 0 form, right? that means we can differentiate, we can use L'Hopital rule. So it is going to be limit a tends to 0, and what's the differentiation of some constant to the power x or e to the power x or something. So the differentiation of this is a to the power x into log a, right? But here this x is the constant, right? So the differentiation of this would be x to the power a into log x minus 0 divided by the differentiation of a is 1, right? Now we can put this a is equals to 0, that will give us log x. So the correct answer for this is A. So this question is from 2014 CE. So so we have to evaluate this limit. So what we can do is x divided by x, that is going to be 1 plus sine x divided by x, that is limit x tends to infinity. So that is going to be 1 plus limit x tends to infinity. What will happen to this if we put x tends infinity? So this, the range of this is from -1 to +1, right? And in denominator it is going to be infinity. So something finite divided by infinite, that is going to be 0. So 1. So this question is from ME 2014. We have to find this limit. If you put x is equals to 0, x is equals to 0, so that is going to be 0 by 0 form. So we can apply the L'Hopital rule and we can differentiate that. We are going to get this divided by cos of 4x into 4 limit x tends to 0. Now you can put the limit, that will be 2 divided by 4, that is 0.5. So this question is again from ME, and if you put x is equals to 0, so 0 minus 0 divided by 1 minus 1, that is 0 by 0. So 0 by 0 form, you can apply the L'Hopital rule. So that will bring you 1 minus cos x divided by 1 plus sin x limit x tends to 0. So that is going to be 1 minus 1 divided by 1 plus 1, so 0. So this question is from EC 2014. So this is a standard limit. So if you put infinity, that is going to be 1 to the power infinity, right? So, and this is your fx. So if you put infinity, that is going to be 1, and this is your gx. If you put infinity, that is going to be infinity, right? So how we can, we have e to the power limit x tends to infinity fx minus 1, right? So fx is 1 plus 1 divided by x minus 1, and gx is x. So that is going to be cancelled, this is going to be cancelled. So overall E. So the correct answer for is C. So this question is from ME. If you put limit x to 0, 1 minus 1, that is 0 divided by 0. So this is 0 by 0 form. You can apply the L'Hopital rule. What you are going to get is sin x divided by 2x, right? Limit x tends to 0. Now again this is a 0 by 0 form. You can double differentiate it. Limit x tends to 0, sin x is cos x divided by 2, right? Now you can put the limit, so it is going to be 1 divided by 2, that is B. This question is from C 2010. So again 0 by 0 form, or you can relate to this sin x divided by x, limit x tends to 0, that is equal to 1, right? So you can, so what you can do here, 2x divided by 3 is there, right? So you can make it 2 divided by 3, and you can also divide it by 2 divided by 3, right? And now this limit is going to be 1, right? Now the answer would be 2 divided by 3. This question is from CS 2010, and again this is a form of 1 to the power infinity, right? How we can solve this type of form? What we can do is e to the power limit x, sorry, here n tends to infinity is right, n tends to infinity. So fx is 1 minus 1 divided by n minus 1 into gx is 2n, right? So this is going to be cancelled and this is going to be cancelled. So overall what we are going to get is e to the power minus 2. So if you put 8 here, that would going to be 2 minus 2, that is 0, and 0 divided by 0. So it's the 0 divided by 0 form. So how we can solve this? We can differentiate. That is going to be x1 1 minus 3 by, so that is going to be n minus 1, right? So that is 1 minus, so minus 2 by 3 divided by x is 1, limit x tends to 8, right? So that will be 1 divided by 3 into 2 to the power 3 into minus 2 divided by 3. So overall we will have 1 divided by 12. So the correct answer is B. So this is from 2008 CS, limit have given. If you put, then what we can do here is we can divide by x, and here also we can divide by x. Limit x tends to infinity, so we will get 1 minus limit x tends to infinity sin x divided by x, 1 plus limit x tends to infinity cos x divided by x. So this is finite and this is infinite, that will be 0. Again this is finite and this is infinite, that will be 0. So 1. Okay, so this question is from 2004 and this you put 0 0, so that is going to be 0 by 0 form. Again you can apply the L'Hopital, so that will give you 3x square plus 2x divided by 6x square minus 14x. Again it will be 0 by 0 form. So what you can do, you can differentiate it again. So and you will put that is going to be 1 by 7, right? So the correct answer for this C. So again this is the easy question. Limit x tends to 0 sin square x divided by x. So how you can think is that limit x tends to 0 sin x into, or maybe sin x divided by x into sin x. So this will be 1 into, again limit x tends to 0, that will be 0. So 0. So the correct answer for this is A. So this is from 2001 IM. So how you can proceed with this? You know that sin x limit x tends to 0, that is 1, right? So you can make this one similar to this by multiplying it with 2, and to adjust this you will have to multiply here with 2, right? And this limit is 1, right? So 2 times 1 is 2. Okay, so this question is from 2001 CE. Limit of the following series as x tends to pi by 2. We have given this series, right? So this is the expansion of which function? So this is the expansion of sine x, right? So this fx is nothing but sine x. Now x tends to pi by 2, that is 90 degrees. 1. Okay, so if you put x is equals to a, then it is going to be 0 to the power 0. So this is also one of the indeterminate form. So how to approach this question? What you can do, you can assume that y is equals to limit x tends to a x minus a x minus a, right? Now you can take log both side. So if you take the log both side, that is what you will get, right? Now you see that this is again a 0 into infinity, that is again a indeterminate form, right? So Now what you can do, maybe infinity into infinity, right? No, 0 into infinity. So what we can do, maybe log x minus a divided by 1 upon x minus a, right? So that is going to be infinity by infinity form, right? Because if you will put limit x tends to a here, that is going to be 1 divided by 0, that is infinity, and log 0 will tends to infinity. Now what you can do, now you can apply the L'Hopital rule. So if you apply the L'Hopital rule here, log x is 1 by x, so it is going to be 1 divided by x minus a, right? And divided by, this is nothing but x minus a to the power minus 1, so that is going to be x minus a to the power minus 1 into, sorry, minus 1 minus 1, right? So that would be x minus a to the power minus 2, right? So that will be limit x tends to a x minus a, so this is 0. So overall this log y is equal to 0, that means y is equals to 1, so this limit is 1. So how you can solve this limit? So what you can do, you can take n, that is n square common from denominator, that will be n, and here you will have 1 plus 1 divided by n, right? This n will get cancelled. Now if you put limit n tends to infinity, this is going to be 0, so overall you will get 1. So this is next question, we will have to find this limit x tends to 0. So if you put 0 here, that is going to be 0 and 0, so again 0 by 0 form you can apply the L'Hopital rule. So that is going to be 1 divided by 10 and j5 e to the power minus j5x divided by j, okay, so here 5 is not there, right? Only jx is there, so j e to the power minus jx. Now you can put limit x tends to 0, so that will give you 1 divided by 2, that is 0.5. Okay, so in this question that x is 0 here, right? And this is going to be infinity, and that sign will vary from minus 1 to 1, right? And this x can take any value, right? So this is something 0 into some finite value, that is going to be 0. Okay, let's try this question. Limit x tends to infinity, so that will be infinity by infinity, I think. So we can differentiate, so 3x square minus plus sin x divided by 2x plus 2 sin x cos x, right? Even if we take the common, and it will get divided, limit x tends to infinity, that will be infinity, right? Because if we take the common x square, right, or then here we will have x square, and limit x tends to infinity, that is going to be 0. Similar for this, right? But here we will have some x term, right? And if limit x tends to infinity, and this denominator is some finite, right? So that is going to be infinity, so the correct answer is A. Okay, so let's look at this question. So if you put limit 0, so this will be 0 by 0 form. We can apply the L orbital rule, so differentiate numerator and denominator. So it is going to be e to the power x minus 1 plus x into e to the power x plus minus 2 sine x, and here that will be 0 divided by x. Here we will have x 1 minus cos x plus x times of sine x, right? Now if we put limit, that is again going to be 0 by 0 form. Now we can again differentiate it, so that will be e to the power x plus x into e to the power x plus e to the power x minus 2 cos x divided by, that is going to be sin x plus x cos x plus sin x, right? Now if we put limit x tends to 0, that will be 1 0 1, and this is again going to be, I think, 0 by 0 form, because this is 1 1 and minus 2, so that is 0, so 0 and 0 and 0, so this is again 0 by 0 form. Again we can differentiate, that is e to the power x plus x e to the power x plus e to the power x plus e to the power x, so that is going to be 2 sin x divided by cos x plus cos x minus x sin x plus cos x. Now put, so that is going to be 1, this is 0, this is 1, this is 1, and this is 0, so 3 divided by 1 1 0 1, so 3 divided by 3, that is 1.